Good morning everyone, I hope you had a lovely weekend. Today we're going to be looking at how to solve some fractions, but with problems this time. So kind of building on our work from last week. I know some people were telling me they had some trouble with fractions, so this is a good opportunity to rehearse it a bit more. And that's what we're going to do here. And look at these fractions. We've got 2/3, 6/9, 1 3/4, that's of course a mixed number, 7/4, an improper or top-heavy fraction, and 4/6. When you think, what can you tell me about these fractions? And if you're struggling at all, or in fact just generally, I think it's a good idea to draw a model, support your ideas. So make sure you've got a pencil and a piece of paper or some other way to draw it now. Pause the video and give that a go, then we'll go through them together. If you come back to this and you're still struggling, the word equivalent is the important one you want to look for here. And now let's have a look at it. So if we are going to figure these out, then let's draw a model. Now when we draw a model, we generally want to make the whole the same size. So what we're going to do is, I'm going to get this and we're going to put it on infinite cloner. So now if I drag one down, it'll be the same size as the one above it. There we go. Now for the first one, I've got 2/3. So I want to split this into 3. Like this. Okay, so I've got 2/3. Now, if I want to make something into ninths here, I know that's not the best drawing. If I want to split something into ninths, what I'm going to do is I'm going to use the fact that I know that 3 times 3 is 9. So I'm just going to take this down here, and take this down here, and I'm going to split it horizontally into thirds like this. Okay, so now what I have is I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I shade in 6 of them, oh, do you start to notice what's happening? That's 3 of them, 4 of them, 5 of them, 6 of them. That's right. 2/3 is the same as 6/9. All it is we've got the 2 times 3 has become 6. And, sorry, I realised I made a mistake. I've written over 3, of course it should be over 9. My mistake. And 3 times 3 is also 9. So we've done the same thing to the top and the bottom. The fraction is equivalent. The same proportion is shaded. How about the next one? We move this over here for now. 1 3/4. So I've got 1. And then I've got another one, haven't I? Because I've got 1 whole shaded. So I'm just going to fill that one with blue. And then I want 3/4. So I'm going to go 1, 2, 3 here. Okay. Let's hopefully the fill works. No, it does not. So I'm going to have to do it manually. So 1, 2, 3/4. Okay, I've got 1 3/4 here, right? Should be happy with that. That's 1 whole. This is 3/4. What about next if I got 7/4? Well, just to save space, what I'm going to do is I'm going to split this one into quarters. I wonder what will happen. I know the best mathematicians I will already be looking at this, crying out what's happened. Well, of course, 1 whole is the same as 4/4, and 4/4 plus 3/4, that is 7/4. So these two are the same, and these two, well, that's a nice shade of green, these two are the same as well. What about 4/6? To make some space, I'm actually going to get rid of this now. And I'm going to take this again, I'm going to try and make 4/6 out of it, let's see. So, same idea, if it's 6, I'm just going to split it into thirds. And then I'm going to split this in half. So now I've got it into 6 sections, and if I want to do 4 of them, I've got 1, 2, 3, oh look at that, 4. That's 4/6, which is exactly the same as the 6/9 above it, which is exactly the same as the 2/3 above it. And in this case, you can see that 2/3 is the same as 4/6, because you just multiply this by 2 and this by 2. If you do the same thing to the top and the bottom, they are going to stay equivalent. The amount is not going to change, it just changes the way you do it. Remember, the number with the smallest numbers, that is the simplest form. In this case, we can say that both 4 and 6 are in the 2 times tables, both 6 and 9 are in the 3 times tables. So you can think of it by doing it the other way. If you do the opposite of it, instead of multiplying by 2, you'll just do the inverse. What's the inverse? Of course, it's division. So you can say here that this is divided by 2, and this is divided by 2. And of course, this would be divided by 3 and divided by 3. So, going through this, we're now going to think about this. Normally we'd teach a partner. Of course, you don't have a partner, but if you are working with someone at home, maybe a sibling or a mum or dad, it would be a good idea if you could do this. Please don't bother your parents if they are working, though. Of course, everyone has their own stuff to do. But if you are able to do that, pause the video. Otherwise, we're going to go through it now. So if we're adding fractions, let's say we've got something like 3 quarters plus 1 quarter. Of course, that's going to be 3 plus 1 is 4. The denominator doesn't change. That's going to be 4. Of course, 4 quarters is the same as 1 whole. So that's one way of doing it. What about if we have fractions that don't have the same denominator? Let's say we've got 1/5 plus, let's say 3 quarters in this case. Well, now, and this is something that's going to come up in our arithmetic test, and we're going to be doing arithmetic tests on Friday, if anyone hasn't checked the overview. So you want to take these and you want to make them have the same denominator, what we call a common denominator. And the way we're going to do this is we're going to figure out a number that's both in the 5 times tables and the 4 times tables. You can always get one of these by doing 5 times 4, right? Because obviously that's going to be in the 5 times table and the 4 times tables. In this case, we're going to say 5 times 4 is 20. So we're just going to do times 4 here. And here we do 4 times 5 to also get to 20. So now if we can do this conversion, we've got two numbers that are going to just add together and they're going to be out of 20, and that's going to be nice and easy. But we need to do the same thing to the numerator, to the top number. So here we've got 1 times 4 is 4, 3 times 5 is 15, and that means that this is going to be 4 plus 15 is 19. Once we've got them the same, we don't change the denominator. We only change the denominator when we are, when we are dividing them maybe, or if we are converting them to be a different thing. How about if we multiply fractions? Again, this is what we did last week, so it's good practice if you don't remember. When you're multiplying a fraction by a whole number, you just do something like, let's say you've got 2/3 times 5. Of course, many remember the denominator does not change. We're not converting it. So the denominator is going to stay 3, and then we're going to have 2 times 5, which is 10. So that's going to give us 10/3. What does that look like, though, as a mixed number? Well, a couple of ways you could do it. You could draw out a model where, in fact, let me insert a table with just 3 columns and 1 row. There we go. That'll be a nice bar for us. And we'll make this the infinite clone again. So now I've got this, and I'm going to say I want, oh, here we go. Oops. 1, 2, I've still only have 6 of them, so let's grab one again. 3, I've only got 9 of them, so I'm going to need a 4th one. Having some difficulty grabbing that one, there we go. And now if I shade them in, this time I'm going to use a highlighter just to make it look a little bit neater. Oh, in fact I can use the fill tool, can't I? I'm going to go 1, I cannot use the fill tool, it's just the highlighter. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them, but that is 1 hole, 2 holes, 3 holes, and 1 out of 3, so 3 1/3. The other way you can do it is by doing division. If you do 10 divided by 3, what you'll find there is you've got 3, because 3 times 3 is 9, and a remainder of 1, which is the same as 3 and 1 over, in this case, the number you are dividing by, which is here. So you're going to do 1 over 3, or 3 1/3. So just different ways of doing the same thing. It's important you can do this skill, because this is what we're going to look at for our problem solving in the next section. Now, Excuse me, I'm a bit sniffly today. What we're going to try and do is look at some of these numbers from before. We're going to multiply 2/3 and 4/6 both by 3. Give this a go and then come back and we'll try it together. Now, when you've tried to do it, you should probably remember that, like the very beginning, 2/3 and 4/6 are the same thing. So our answer is going to be the same thing. It's just going to look a bit different. But let's try it just with the numbers here. We've got 2/3 times 3. Our thirds is not going to change. We're just going to do 2 times 3 is 6. And 6/3 is the same as 2 wholes. Let's look at that with a model. If I insert the table once more, here we go. I'll just move that down here. What I've got here is 6/3, so I want to shade in 6 of them. Probably many of you can already see this. 1, 2, 1, 2, 1, 2. That's 6/3, and of course it's 2 wholes because we've got 1 hole here and 1 hole here equals 2. Now, what about if we do it with 6? Well, it's really simple. We're just going to draw a line through the middle. Remember? Let's do it with the numbers just to check we're not jumping any hoops here. 4/6 times 3, same idea. The denominator isn't going to change, the numerator is going to stay 6, and now we're going to have 4 times 3 is 12. But 12 over 6 is still 2, count them. 1, 2, 3, 4, different colour. 1, 2, 3, 4, and a different colour again. 1, 2, 3, 4. I've got 3 lots of 4 over 6, and I've still got 2 wholes. That's because they're the same thing. Could you test it with your own example? See if you can come up with one. If not, I'll give you one shortly. Not sure about which one to do? Try 1/2 times 4 and 2/4 times 4 and see what you come up with. Okay, moving on from this, here's your independent task for today. There are 4 challenges here. You can choose the order you want to do them, but I would like you to try all 4 challenges. There's not very many bits of them. You'll see you've got I, and I for A, so each of them is about 3 bits. You're going to need to put the fractions in order, sometimes add them, sometimes take them away. Remember, taking them away and adding them works the same way, it's just the opposite, and multiplying them. So if you're not sure about adding and multiplying, make sure you look back at the previous parts of the video. I'm going to put this as a PDF, the challenges, on Powerful Mash, so if you're struggling to see them here in the video, you can have a look there. Good luck, and don't forget to email me your work with how you get on.